you're here? Well, let's get started then. All right, we are dividing with fractions and mixed numbers. So it's heavily tied to the multiplying with fractions. You see, because you actually don't divide, all right? Dividing fractions is actually a multiplication problem in disguise. All right, let's walk through this. So like we saw before, we change the mixed numbers to improper fractions if necessary. So I'm looking at question number 7. I don't see any mixed numbers. So, all right, not necessary. Second, we rewrite. The phrase here is you multiply by the reciprocal. So 3/8 times, and the reciprocal means to flip. All right? So you're going to take that denominator and make it the numerator. Take that numerator, make it the denominator. Now it's a multiplication problem, and we're just going to pick up where we did yesterday. Look for cross division. I see it. I see the 4 and the 8. We can divide them both by a 4. So 4 divided by 4, 1. 8 divided by 4, 2. Now let's just multiply across. 3 times 1, 3. 2 times 1, 2. 3 halves. Again, if you want to change it to a mixed number, it's fine. I'm not requiring that out of you there. You can leave it as the improper fraction. The only thing here is you might have to still simplify that improper fraction, as in, is there any one you can divide by? No, 3 and 2, the only one I can divide by is 1, and that's not going to change anything. Let's go to question number 8. All right, so again, we leave that first fraction alone. We rewrite by multiplying by the reciprocal, and then we're all about the cross division here again. The 7 and the 14 on the diagonal, we can divide by a 7. So 7 divided by 7 is a 1, 14 divided by 7 is a 2. I can't do anything with that 6 and that 5, so we just kind of have to leave it alone and multiply across. So 12/5. Again, can't divide 12 and 5 by anyone, so we're done. Again, the cross division will help out with the simplifying. All right, let's move on down here and see who else. All right, let's jump into our mixed numbers now. All right, so remember, to change it into an improper fraction, no, magic doesn't work. All right, we need to multiply the denominator by the whole number and then add it on. So 6 times 7 is a 42, plus the 1 gives me a 43, so I have 43/6. Again, the idea behind it is you've got 7, 6, 6. So you could do 6, 6 plus 6, 6 plus 6. No. All right, algorithm, let's speed things on up here. The 2 and the 7 12s. Okay, multiply 24, 12 times 2, plus the 7, 31. So I've got a 31/12. Some of you are going to want to rewrite at that time. That's your choice. I choose not to. I'm going to rewrite it in the next step, 43/6 times 12/31. Again, I'm looking for cross division. I see it with the 6 and the 12. Let's divide them both by 2. Well, it's a big 3. Well, 6. I want to use the largest one. Now, if I use the smaller one, I could just do more cross division there. But we're going to divide them both by 6. So I get a 1 and a 2. We can multiply across. 43 times 2 is an 86. 1 times 31. There we go, 86/31. Again, moving down the road there, improper fractions are used, and the mixed numbers really are not. Let's hit one more here. We'll finish off with question number 12. Again, let's change them into the improper fractions. 4 times 3 is 12. 12 plus 3 is 15, so I have a 15/4. 12 times 2 is 24, plus the 1 is a 25. So I got 25 halves. Again, I'm going to choose to take the 2 steps. Now I'm going to rewrite 15/4 times 2 25ths. We like this one because of the cross division. There's your basic 2 and the 4. A lot of times you'll be able to divide by the smaller number. In this case, that's what happens. 2 divided by 2 is a 1. 4 divided by 2 is a 2. I really like the other one. You can't divide by 15, but you can divide by a 5. Yeah, we can divide both those numbers by 5. So it's not always about the little number fitting into the bigger number. Check for that, but just make sure we can divide by both of them. So I take 15 and divide by 5, I get a 3. I take 25 and divide by 5, I get a 5. Let's multiply across. 3 times 1, 3. 2 times 5, 10. And there we go. 3 tenths. We're done. All right. So yeah, steps are involved. Multi-step, using our computation, all those types of things. But go ahead, people. Set your alarm. All right. You can go back to sleep now. We'll see you later.